Okay, so hi guys. I want to apologize for the lack of uploads. It's been pretty crazy, but I'm gonna do, so in this video what we're gonna do is we are gonna go over factorials. I don't think I've gone over these in my YouTube channel before, but I want to go over these because in sequences and series they go over these. So if you've never learned about factorials before, this is kind of like a prerequisite to the idea of sequences and series. So I just want to go over some terminology and some examples of, how to evaluate and how to simplify, expressions where we are doing factorials. So here, I have some definitions. So a factorial, so basically it says factorial, so if n is a positive integer, then n factorial is defined as n factorial equals 1 times 2 times 3 times 4 times ... times n minus 1 times n. So this is like not it's an exclamation mark, but like it's not like they're yelling the number now. It's more like this is really the definition of it. So I'm gonna go over some examples here, and let me do lined paper. So like I said, this is just gonna be a kind of prerequisite or introduction to factorials. I might also go over some factorials when it comes to algebraic factorials. So I will do that in this video as well. So this first one, right? If I, for example, want to define or I want to simplify 2 factorial over 5 factorial, it's basically going to be, so we have 2 factorial over 5 factorial, and we're going to do, it's going to be the following. So it's going to be like this. Sometimes they do 1 times 2 times 3 times ... and others go backwards. So they're like 2 times 1 times whatever. So I'm going to just do it in the kind of, I guess, elementary or kind of basic way idea. So here we're just going to do 2 times 1 because 2 factorial, again, any number that's factorial, you either increase or decrease to that number. So if it's like 2 factorial, I go 2 times 1, 5 factorial, we're going to do 5 times 4 times 3 times 2 times 1. Usually you don't include 1 because it's really not needed. If I, for example, say like 2 factorial, it's really just 2. As a special case, I forgot to mention, 0 factorial is 1. So that is one of the things that we have to keep in mind. So here we're going to end up with 2 over 5 times 4 times 3 times 2. So basically it's gonna, these are going to cancel out, and we're just going to be left with 1 over 5 times 4 times 3, which is 1 over 20 times 3, which would be 1 over 60. It does get harder as we go over more examples. So this is just one example. Let's do another similar to that one to just kind of, introduce ourselves a little more so that you guys can see the kind of the pattern here. So another one I can come up with, I think I went, okay, no. So let's do number 2. Let's try to do, 1 second. Okay guys, let's do this one. So 2 factorial plus 5 factorial. Now, I am going to go over the next two examples. I'm going to try to compare them. So this is one of them. Let's just go ahead and do it. So again, 2 factorial, pretty easy. It's 2 times 1, just 2, right? And then 5 factorial is really 5 times 4 times 3 times 2. And again, I'm not going to include the times 1. In fact, this should have just been 2, but I'm only doing it so that you guys know why it's equal to 2. And so then we're going to have the following. So, 1 second. Okay, guys, so this is what we would get. So then, now we're just going to simplify this stuff. So, this will be 2 plus, and let me just draw like a, kind of like that. And then so we have 20 times, so this becomes a 20. This is 6, so 20 times 6. And it's going to be 2 plus 120, which is 122. So 2 factorial plus 5 factorial is 122. Okay. And so now the next example that I want to go over is a little bit, it looks similar, but it's going to be different. It's not the same thing. So number 3 here, let's try to do one where it's actually like this. So 2 plus 5 factorial. Okay. Now we're going to do this example, and I want you to notice the difference between these two, and then I'll go ahead and explain what the actual difference is and what we need to remember. So here we know that on the inside there's a 2 plus 5, so we have 2 plus 5 factorial, but we need to simplify the inside, right? Because we can do that. We can add 2 plus 5. It's going to be 7 factorial. And so then this is going to be 7 times 6 times 5 times 4 times 3 times 2. Okay, this is 42, 20, and 6. So now, I mean, obviously, if we use a calculator, 1 second, guys. Okay, guys, so this actually simplifies. So it's going to simplify to 5040. So we know that basically 2 plus 5 factorial should be a 5 is equal to 5040. Here's the thing I want to make very clear. So when we did number 2, this was 122, because there's a factorial that, you know, they both have a factorial. But when the factorial is on the outside like this, it does not give us the same thing. So one of the things I want to make very clear here is that if we have something of the form, and let's do a plus b, let's do a plus b factorial, this is not equal to, and it's not going to be equal to, what is it, a factorial plus b factorial. And I do believe it is the same idea for subtraction as well. So basically, plus or minus, I would say. So I really want to make that clear, because I feel like a lot of people can make that mistake. We're not going to distribute the factorial. You don't do that. This is not it. The factorial is, it's really, what this means is that it's basically the entire expression that is factorial, but it does not mean that we're actually adding 2 different factorials in here, because it's not the same thing. So I just wanted to show y'all that kind of example. Okay. Okay guys, I'm so sorry for the long pause. It's been like a few hours. So let's go over this example. So we have 10 factorial times 6 factorial over 4 factorial times 9 factorial. So let's see, hold on. So we have this following stuff here. So let me just go ahead and okay, so obviously, so let's kind of go ahead and look at this more thoroughly. So 10 factorial, we know that 10 factorial is 10 times 9 factorial. Okay, so we know that that is what that part is, 10 times 9 factorial. And then we have a times 6 factorial. And on the bottom, we also have a 9 factorial. And then we know that 6 factorial itself is really going to be the following. So we're going to do 10 times 9 factorial over 9 factorial. And we still have that times 4 factorial. I forgot to put that in there. And then we're going to have, it's going to be times, and it's going to be 6 times 5 times 4 factorial. And then from here, we're going to do, so it goes kind of like this, right? And so then from here, we know that the 9 factorial cancels out, and that the 4 factorial also cancels out. So then this gives us 10. This gives us the remaining parts, which are 10 times 6 times 5, which is really going to be 300. So okay guys, so that is how we do this one. I do want to go over some algebraic examples involving factorials. So this is also going to include that, those kind of problems. So let's see. If I look at, let's look at a more difficult, or let's look at one that's actually algebraic. So give me a second, guys. 1 second. Okay, guys, so let's get this one now. So this one is a little bit different. So it's a little harder, actually, than the previous ones. Now we're getting into actually doing some with algebraic expressions. So we want to find what this is. And the way that this is going to work, and I'm going to write it the following way. So I'm going to label my n term here. So I'm going to kind of color code this. So I'm going to say that this is equal to the quantity n plus 2 factorial over n minus 1 factorial. So the n's are going to kind of be color coded here so that I can show y'all how this works. And we know that anytime we are going from we're basically descending. So if we think about it, let's see, hold on guys. If we think about it, this is really going to be the following. So we know that we're starting with n, but we're going to go downwards. So this is going to be n plus 2. So really we're going to do n plus 2. And then what I'm going to do is I'm going to multiply, and I'm going to subtract 1 to this n. So basically I'm going to say n minus 1, and I'm going to put that kind of in parentheses like this, and then I'm going to keep going plus 2. Okay, and then I'm going to keep going. So then it's going to be times, and it's going to be n minus 2 plus 2. So then we're just going to keep going. So it's going to be, the next one will be n minus 2. So really, the way this works is we're going to be going from n minus 1, n minus 2, n minus 3, so on and so forth. And you'll see how this simplifies, okay? So then, if we do this, and let's just keep, and let's, on the bottom, let's actually do the same thing. So, this is going to be, it's going to go like this. N, so we're going to do n minus 1. And then times, and it's going to be n minus 1 minus 1, so. And then, sorry guys, just 1 second. And then times n minus 2 minus 1, so. So this is kind of the way that we're doing it here. And then times, and it's going to be n minus 3 minus 1. So if we kind of keep doing this, you'll see that this will actually simplify to an algebraic expression. N minus 3 minus 1, like this. So then if we look at this, right, we're going to do, let's see, so n minus 1 minus 1. So then this will be n plus 2, and then times n, times n plus 1 times n, and then over, it's going to be n minus 1 times n minus 2 times n minus 3, and so on and so forth, right? So give me 1 second, actually. Okay, guys, so if we keep going here, so this is where I was getting to. So on the numerator, if we keep going, it's going to be times n minus 3 plus 2. So really, it's going to go like this. And this is just to show y'all what I'm talking about. So really, this will be the following. It's going to be n, so it's going to go n plus 2 times, and then this stuff here is n plus 1. And then this stuff here is just n. And if we look at this part here, this is n minus 1. And on the denominator, we're going to have n minus 1, and then we'll have the following. So it'll be times n minus 2 times n minus 3 times n minus 4 times dot dot dot. And if we keep going downwards here, so it goes from 2, 1, 0, negative 1, and obviously it'll be times n minus 2 times n minus 3 times n minus 4 times dot dot dot. So then obviously, guys, if you look very carefully, these will cancel out. All of these, any term after that will cancel out. So what are we left with? We are left with this stuff here. So then this will be equal to n times n plus 1 times n plus 2. If you want to multiply all of those. Let me go ahead and do that. So then, doing so, we will get the following, right? And so we now know that for this problem, n plus 2 factorial over n minus 1 factorial is actually going to be n cubed plus 3n squared plus 2n. And it is a polynomial function of n. So it's a cubic function. So that's kind of the idea of factorials, guys. I don't know. I mean, these are just kind of the, I wouldn't say basic, since for this problem, I went a little more tougher. But that's kind of how it goes with these. It's just about having to go, like, you have to read it very carefully, and then obviously do, do some algebra and just simplify it as much as you can. So if anybody does want more examples like number 5, let me know. Other than that, this is kind of concludes the idea of factorials and how they kind of work. So with that being said, guys, that is going to be it for this video. Thank you so much for watching, and also please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.